job is to isolate this sine x. Notice I didn't circle the square. That has to be gone. So to isolate this, the first thing I'd probably do is add 1 to both sides. That would give me 2 sine squared x equals 1. Then we would divide both sides by 2. That would give me sine squared x equals 1/2. Most of us should know what to do. If I need to get rid of a square, I use the square root. So we're going to take the square root of both sides. Let's do that in orange. Now the big thing, when you are the one that took the square root, you have to add your plus or minus. I saw people lean back down to fix that. So we have sine of x equals plus or minus. If I have a square root of a fraction, I can make the numerator a square root and the denominator a square. Oh, does everyone have these notes?
Oh, I don't.
Yeah, sorry.
I print them out, but I don't.
Okay. I have, what's the square root of 1?
1.
What's the square root of 2? Some decimal, right? And the only reason why I say that is because on last night's homework, some people got stumped by the square root of 4. If you can find the square root, find the square root. I can't find the square root of 2, so we need to move that to the top using multiplication. At some point, it'd be good of you to realize that 1 over square root of 2 equals square root of 2 over 2. But if you're ever uncertain, just multiply the bottom by square root of 2, the top by square root of 2. And you should come up with this being square root of 2 over 2, but you need to include that plus or minus. Now, what this is actually asking is, where is sine equal to square root of 2 over 2? And it can be either positive or negative. So we're going to put those answers down there. Can someone tell me one angle where sine equals square root of 2 over 2, whether it's positive or negative? Pi over 4. Can someone else raise your hand and tell me another one? Yeah.
3 pi over 4.
3 pi over 4. I need another one.
5 pi over 4.
Okay, 5 pi over 4. I need one more. 7 pi over 4 would be correct.
How many do you want to actually all of them?
Whatever I just wrote down is your answer. You have to write down all of the angles at work that are between 0 and 2 pi. That means no coterminal angles, so I don't have to keep adding 2 pi to these, but I need to have all 4 of those answers. So what this is saying is 0, 2 pi, look at your unit circle and find out all the places that it's true at. Now, I bet you any money if you plug in, for people that are slightly confused, if you find the sine of 5 pi over 4, go to your unit circle, look at 5 pi over 4, your sine should equal a positive or negative square root of 2 over 2, and it will be a negative square root of 2 over 2. So I'm just showing you the 4 places on your unit circle that would either be a positive square root of 2 over 2 or a negative square root of 2 over 2. Now, that's what I wanted you to get out of yesterday's lesson. Do we have questions on what I just did? Okay. I'm going to skip to today's lesson. I know we have questions. I'll hold on to those till the end to make sure we have time, but I want to get this down. Because if you know how to do this, you can do today's lesson. Just this one problem pretty much tells me you can do today's lesson. Now, the big thing about today's lesson, which I'm going to point to right now, see that little guy? It says I'm supposed to find all the exact solutions between 0 and 2 pi. Maybe I'll highlight that versus doing that. Use blue. That tells me I look at the unit circle and I find, it tells you there's a finite number of solutions to this. Now, juxtapose that to what I'm going to ask you next. In example 1, it says find all real numbers that satisfy each equation. No longer are we constrained from 0 to 2 pi. We open up Pandora's box, kind of, and include all possible solutions. That's kind of a problem because if you add 2 pi to an angle, you're still at the same place. If I have pi over 6 and I ask for the sine of pi over 6, you say it's 1/2. If I add 2 pi to that, it's still 1/2. If I add another 2 pi to it, it's still 1/2. This is telling me I have to give an unlimited number of solutions. I doubt we're going to list them all, but we're going to find a way that we can say, oh, it's all of these angles. So let's take a step back and pretend this was yesterday. Yesterday I said isolate the trig. It's already isolated. Cool. This is just asking me where is cosine equal to square root of 2 over 2? Where is cosine equal to square root of 2 over 2? And can someone give me an angle where cosine equals a positive square root of 2 over 2? Yeah, go ahead. Pi over 4. Perfect. So at pi over 4, that can be one of our solutions. Yeah. 7 pi over 4. which would be right here. Why did no one tell me like 5 pi over 4? Okay, so I just look at the places where it's positive because they asked for it as positive. Okay, so if this was yesterday, I'm going to label this just a little bit different. If this was yesterday, I would have x equals pi over 4, and I would have x equals 7 pi over 4. And I'd be done. Yesterday, I'd be done. That's it. These are the solutions from 0 to 2 pi, but this says list all possible solutions. So if you go ahead and look at that pi over 4, if I was to add 2 pi to this, so if I went all the way around, added 2 pi, plus 2 pi. If I added 2 pi to this, we would have, what, 9 pi over 4. That's a correct answer. So that means I have to put 9 pi over 4. But then I can add 2 pi to it, and 2 pi to it, and 2 pi to it, and that sounds like a miserable way to do this. So what we're going to do instead is we're going to say, well, pi over 4 is an answer, but we know all coterminal answers are also work. So what we're going to say is, well, if I added 2 pi to this, it would work. If I added another 2 pi, it would work. If I subtracted 2 pi, it would work. So what we're going to do is we're going to say it's plus 2 pi times, and we're going to multiply by n, knowing that n is an integer. Now you're going to look at my answer key, and sometimes I'll have k in there. K and n are basically our go-tos for saying they're integers. So if you see k's in the answer key, you can leave them as n's, or you can put them as k's. It's up to you. K and n are pretty much the same. That will give you all of the solutions to where you have pi over 4 and coterminal angles. But we have to do the exact same thing to the 7 pi over 4. So I need to add 2 pi n to that one as well. There's a water drop in here. I will note that sometimes I'll write this as 2 n pi. It means the same thing. It's just a little different way to write it. So we basically took what we did yesterday and we added plus 2 pi n. That's all we did. So if this would have said for all solutions, we would have had gone through all 4 of these angles and added plus 2 pi n to n, and we would have been able to do what we did today. We tracking? Okay. Let's do this one more time. We have sine of x equals -1/2. That means I need to find first everywhere on my unit circle equals -1/2. Can someone tell me the 2 places where sine of x equals -1/2? Go ahead.
7 pi over 6.
So, ooh, aggressive too. Yeah, 7 pi over 6
11 pi over 6.
and 11 pi over 6. I just like the assuredness of it. You're just like, I got this. All right, now I'm going to look up there. We want all real solutions. If it said from 0 to 2 pi, I'd be done pretty much. We just put x equals those 2. Because we want all real solutions, we have to put 2 equations down. We have to put one equation for the 7 pi over 6. We'll go 7 pi over 6 plus that 2 pi n. And we need the x equals 11 pi over 6 plus that 2 pi n. You need both of these to have the correct answer. If you know what we were doing yesterday, today's not that bad, right? Compared to some of those homework questions. All right. We'll do the same thing with tangent. Tangent has a slight twist. It doesn't have to have a twist in it. Let's put it that way. If what I explained to you doesn't make sense, we'll do it the exact way we did sine and cosine. So the first thing is we need to figure out where tangent equals 1. Well, tangent equals 1, I'm pretty sure at pi over 4. Is there any other place that tangent equals 1? Yeah, Kyle. 5 pi over 4. Can we all look at that real quick? It's going to be where the twist comes in a little bit. Look at this compared to these. And what I'm looking at is, do you see how this is directly across from each other? And these are not? That's going to allow us to shortcut this if we want to. We don't have to, but we can. Let's pretend I don't know the shortcut because you guys don't right now. So we're going to pretend this is a normal problem where I'm just like, oh, let's just do x equals pi over 4 plus that 2 pi n. My other one is x equals 5 pi over 4 plus 2 pi n. And on the test, you get 100%. You're good. You're right. I'm going to show you a shortcut for tangent and a couple other values. Now, I said it's important about the fact that they're they're straight across from each other. What would the distance be to go exactly 1/2 around the unit circle? Pi, not pi over 2. Pi over 2 gets you 1/4 of the way. This is exactly pi units. If I want to go from 5 pi 4 back to pi over 4, that same place, what would I add? I would add pi. So to get from one to the other, I just keep adding pi, which means I can actually reduce these down to just one equation. So you're going to see this on the answer key. I'll put an or right there. Good. Okay. So I'm going to put this as an or. And what we're going to do is we're just going to list the first angle, pi over 4. And instead of 2 pi n, I'm just going to make it pi times n. I'm just going to keep adding pi over and over and over. It goes between the two things. Now, once again, I put it in blue because you don't have to do that. Either one of these are your solutions. So if this makes more sense to you, then just scribble off the other thing if you're like, I'm not going to get it. If you want the additional challenge, there are chances to simplify things and turn them into one equation. One equation is nice sometimes because then you have less room for error. Yeah.
So that would only work if they're across from each other?
Only if they're directly across from each other. So it would not work here. Because if I took 7 pi over 6 and added pi, I'd be at pi over 6 and not where I need to be. So we can't do that there.
You have pi over 2 on there?
Could I add pi over 2? Pi over 2 would not work either. This is not exactly pi over 2 away from each other. Pi over 2 would actually get you right here.
Oh, okay.
Yep.
So the tangent one, what do you do? X equals 5 pi over 4 plus pi n?
You could. So the question was, could we do x equals 5 pi over 4 plus pi times n? Yeah. As long as we have a good starting angle and we're adding the right thing, then you are correct. Questions on tangent. Don't let that throw you. Don't get to the test and go, oh, tangent's super special. I got to do something crazy about it, but I don't know how, and you make something up. Just, if you forget it, just treat it like anything else. What's going to throw you for a loop, though, is sometimes these. If we look here, it's not the alpha that should throw us, it's the 2 in front of the alpha. So the question is, find all real numbers that satisfy square root of 2, sine 2 alpha equals 1. Compare that to our very first problem, where I had just x in there. This is basically, I now have 2x in there. That 2 alpha is just 2x. Your best bet is to forget about it. Is to completely forget about it and treat it like a normal trig equation. So I'm giving you a hint that sometimes it's nice to just replace 2 alpha with just x or something. So what I'm going to do right off the bat is I'm going to say, well, let's make this easy on myself, and I'm going to let 2 alpha equals x. That's going to make your life easier because now we're going to have square root of 2 times sine of instead of 2 alpha, we're going to have x equals 1. Your job is to pretend this is just a normal sine 1, just like we did yesterday, just like we're doing today. That is your job. Forget about the stuff on the inside of the parenthesis. It'll take care of itself later. Right now, just forget about it. Now treat this as we would yesterday or today, and that is move the square root of 2 to the other side. How do I do that? I have to divide. Now, the other class mentioned, what if I squared both sides? if you square both sides, you have to square the entire side. That's going to end up having sine squared in it. Because you're going to have 2 square root of 2 sine x times square root of 2 sine x. You're going to have 2 sine squared x. They take square root somewhere else. So I'm not going to do that. Instead, we're going to divide by square root of 2 to give us sine x equals 1 over square root of 2. Now, like I said, sooner rather than later, it's nice to notice that 1 over square root of 2 is just square root of 2 over 2. If you didn't realize it or you just wanted to double check, we can multiply the bottom and top by square root of 2. Equals square root of 2 over 2. So now we have this thing that says sine of x equals square root of 2 over 2. Now we are supposed to find all values that work for this. So we need 2 equations. I need x equals something and I need x equals something. Can someone tell me an angle where sine equals square root of 2 over 2?
Pi over 4.
Pi over 4. What's the other one? 3 pi over 4. 5 pi over 4 would put it in quadrant 3 and it'd be negative. Okay, but that's not all the solutions. That's just 2 of them. So I need to add the plus 2 pi n plus 2 pi n. So once again, my advice to you is forget about stuff inside of here. We're going to bring it back in a second, but you have to forget about it to treat it like it's normal. Now we have to realize that I never had x to begin with. I had 2 alpha. So you are now going to take that 2 alpha and throw it back in. So I'm going to take that 2 alpha and I'm going to chuck it. Whoop. I'm going to chuck it back in for that x and that x. And I'm going to do that in the next space down here. So I'm now going to have 2 alpha equals that pi over 4 plus 2 pi n. And I'll also have that 2 alpha equals 3 pi over 4 plus 2 pi n. This is the only time that the 2 matters. I have to solve for alpha. I have to solve for alpha. So now we're going to divide everything by 2. And when I mean everything, I mean go down the line and divide it by 2. Divide by 2, divide by 2, divide by 2. Everything is divided by 2. That's how the division on both sides works. Well, that's going to leave me with alpha. Remember, dividing by 2 is the same thing as multiplying by 1/2. If that makes it easier for you, dividing by 2 is multiplying by 1/2. Dividing by 3 is multiplying by 1/3. So this is going to give you pi over 8.
Oh, you can't just leave it like that?
No, you should simplify. Plus pi n. For other one, we're going to divide everything by 2. We're going to have alpha equals 3 pi over 8 plus pi times n. I guess I could write on there that what I did divide everything by 2, divide by 2, divide by 2, and that's simplified and you are done. For whatever reason, these can be really complicated on the test. I see a lot of people get them wrong. My biggest advice to you is just forget that they're double angled. That's basically what's happening because it's 2 times an angle. It's 2 times x. Forget about what's inside that parenthesis and just treat it like it's normal. And if you remember what to do afterwards, awesome. Here is what's going to make you cost you a ton of points. Let's say I was doing this next one. I'm going to see this on the test. People are going to do this. They're going to divide by 3, and that's going to cancel out. And that's divide by 3. You're losing a lot of points doing that because you just broke math. You just broke math by doing that. Basically what you did is, let's say you had square root of 2x equals 4, and you just divided by 2 to cross out that 2. It doesn't work. You have to undo the operation first. So do not divide out that 3 first. It is trapped in there. That's why I'm pretty consistent at putting parentheses when I write stuff to let myself know it's trapped in there. It's trapped in there until it's gone. So my first advice is replace it with a variable. The other way you can do this is just forget it's there. So rather than rewriting it, you could just go, oh, I'm just looking for where tangent equals negative square root of 3. So it's already isolated. You don't have to do any more work. If there's numbers inside there, it's still already isolated. It's just asking where is tangent equal to negative square root of 3. Well, I know tangent is negative in quadrants 2 and 4. But what angles would those be? 2 pi over 3? You're giving me a 2 pi over 3? Is there any other place where it equals negative square root of 3? You should. Oh boy. Just carry the team. Remember, we should all be looking at our unit circles and making sure this is correct. Are those correct?
Yep.
If you look at 2 pi over 3 and 5 pi over 3, does it equal negative square root of 3? Cool. Now, normally we'd write x equals that 2 pi over 3 plus 2 pi n. And we'd write x equals 5 pi over 3 plus 2 pi n. But this is not a normal occasion. This is where I remember, well, it's actually 3x I was looking for. So rather than putting a variable in its place, we can just think about it smartly and just go, okay, we're looking for where tangent equals, and instead of putting x equals, we're going to put 3x and 3x equals. So this time, instead of dividing by 2, we're going to divide by 3. Divide everything by 3. Let's draw some arrows that say, if I do this, then I'll get out that. That's just an arrow, a terrible arrow. All right, so if I divided everything by 3, we'd have x equals 2 pi over 9. Plus, there's no way to simplify this, so I'm just going to put 2 pi n over 3. Other answer could be x equals 5 pi over 9 plus 2 pi n over 3. Any questions on that? Then I have a question for you. Could we have shortened this problem? It's tangent. I could have, I'm going to put a little star by it. If this doesn't make sense to you, just leave it off because these are your notes. I'll put a little star by this. I could have written 3x equals 2 pi over 3 plus pi times n. That would have been both of these equations written as one. I would have divided by 3 and I would have had one answer. That would have worked. If that doesn't make any sense, don't worry about it. It's just if it makes sense to you, it can shorten the problem a little bit. Yeah?
Yeah, but that went like straight across the unit circle.
It's the one that goes straight across in the unit circle. So if it ever goes straight across, there's always a way to write it as one equation, and then it's just one equation to solve. Does it save a little bit of time? Sure. Is it a game changer? No. I'm going to tell you right now, the test is not very long. The test is, I think, next Thursday for this class. The test is not very long. Think about it. It felt like we covered a lot of ground, but we really didn't. We talked about cosecant, secant, and cotangent and tangent. Then we talked about all their inverses. And then we did this. So what you did on your quiz is a huge chunk of the test. That's why that quiz should be an eye-opener. Either you know how to do this stuff or you don't. You know after that quiz how you're going to do on this test. That test is primarily that stuff. I'll add some graphs on there, like graphing cosecant, maybe a standard. Remember, for tangent and cotangent, I only can ask the basic graph. But for cosecant and secant, I can have transformations. All right, that's a bit off topic. But always good to know what's happening in the future. Let's go over any questions we had either on this stuff or homework questions. Go.
Is the test already made?
The test is pretty much made.
Okay. I'll leave for Kairos on Wednesday. Next Wednesday.
Yeah.
I can take it on Tuesday.
Yeah. I give it on Tuesday, too, for another class. So it'll already be 100% set by then.
I leave as well.
Do you want to take it early or?
Yeah, probably.
Okay, probably.
40 kids.
I'll email you for sure.
Yeah, well, just let me know when you want to take it, whether it's in the testing center or you can come with me before or after.
Okay, cool. Sounds good. Thank you.
Yeah.
Can we go over 13?
Yeah. Let's go over 13. Probably from last night's homework.
Yeah.
That was like 2 nights ago's homework. That's probably not going to help you. 13. Ooh, good question. Good question. Pay attention to this. Would I put this on a test? No. Is this going to be a concept that comes up a lot in pre-calculus? Yes. So whether you copied this or you knew how to do this, pay attention because this is a very important thing that we're going to have to keep track of. Tangent x times cosecant x minus 2 tangent x equals 0. On its surface, it almost looks impossible. It looks like it's going to be really hard to simplify. Here's what we need to realize. Once again, this is really important for us to understand. So I would at least look up here for at least a second. Do you see how tangent's in both terms? I don't have another term there. It's in both terms. If it's in both terms, you can actually factor it out. You can bring it out of there, which is going to look something like this. I'm going to have tangent x times the quantity cosecant x minus 2 equals 0. That's a really slick way to reduce this down. So once again, I just factor out a tangent x, which in this almost feels like I'm just pulling it out front. It is division, but we can just move it out front. That allows me to break this into 2 equations. This is the zero product property. I have something times something equals 0. If I have a chain of things equaling 0, one of them has to equal 0. A times B equals 0, either A equals 0 or B equals 0. So in this case, we're going to have tangent x equals 0 or cosecant x minus 2 equals 0. Well, now we just got to figure out where tangent equals 0. It should equal it at 0 and pi. It's undefined vertical and down below. Wait, did I flip that? Why am I blanking? Hang on, I'm thinking of something. No, that's right. It's at 0 at pi. And then cosecant equaling 2. Well, that's the same thing as me asking where sine equals 1/2. Well, it equals 1/2 at pi over 6. And it also equals 1/2 at 5 pi over 6. But the big thing I wanted you guys to look at is this step here. Do we all at least look at it for a second? Try to pretend like you care for a second? Because we're going to get into identities, and this is a big thing to do to help us with identities. So not so much for this test, but in the future, that's going to be a huge deal that you recognize that. Did all those steps at least kind of make sense? Okay, good. All right, other questions? Yeah, go. 15. 15 is a big factoring one, right? Let me rewrite it real quick. I'm picturing this as being 2x squared plus x minus 1. Understanding that those x's are in place of the cosine x. So to factor this, I told you I'd pick ones that you can kind of guess and check your way through. I'm going to get the first term correct and the last term correct. The first term comes from the first 2 terms in the binomial. So to get 2x squared, I must have a 2x and an x, because 2x times x is 2x squared. To get a 1 out, I have to have a 1 and a 1. Well, it has to be a negative 1, so I need to have one that's positive and one that's negative. We could just guess. I don't know if this is correct. We'll check it. So the way I'm going to check this is I'm going to say, okay, the last term is multiplied plus the middle term is multiplied have to equal that middle term. So right now I have 2x minus 1x. 2x minus 1x equals, I guessed right. Sometimes you'll guess wrong and you have to put the negative on the other thing. So now we have basically 2x minus 1 equals 0, or x plus 1 equals 0. If I move the 1, divide by 2, I have x equals 1/2. And the other one, I have x equals a negative 1. Now, just a reminder that these were actually in placeholders of cosine. Do you think that's far enough? What was that? I already did them equal 0. I had that 2x minus 1 equals 0, and I solved it, and I put cosine x in the place of it. Do you want me to keep going?
Yeah, you got everywhere cosine equals x.
Yeah.
Everywhere cosine equals.
No, I got that. I'm just asking if he wants to see the next step.
Yes, sure.
You want to see the next step? Okay, so I'm asking, where does cosine equal 1/2? Well, cosine equals 1/2 if you look at your unit circle at pi over 3 and at 5 pi over 3. Then the next question says, when does x equal a negative 1? Or when does cosine equal a negative 1? Well, that's going to be at pi. And those will be your 3 answers. Okay? All right, anything else? Okay, I think you guys have about 5 minutes left. I think we end a little late today.